Bafetu, another one from AmaFama. Welcome. Yeah, you know what, Ne? One thing I appreciate about the agri sector in South Africa is that it is growing at a rapid pace. So for example, if I take two farmers, one who farmed 30 years ago and one who farms now, these two people do the same thing but completely differently. So we're going to be exploring seed technology. I mean, how far have we come? In studio with me, I have a well-known face in agriculture. I mean, he was here the last time. We had a lekker chat, so we decided to bring him back. It's the first time in AmaFama history we bring somebody back. So guys, we're going to be talking to Andrew from Sacta, but let him do all the talking for now. Andrew, welcome back.
Thank you very much. It's really nice to be here.
So Andrew, I mean, you're well known in the agri sector, but for those of us who don't know who you are, can you please briefly tell us who you are and what you do and where you're from?
Yeah, so I'm Andrew Bennett. I'm currently the CEO at Sacta. If we went back a really long way, you'd find that I'd studied entomology at university, and I worked for the ARC, Agricultural Research Council, on tobacco and cotton. My field of study was actually entomology, which is insect pests. And then subsequent to that, I spent about 20 years with Monsanto. And as I say, now I'm at Sacta. So speaking of the 20 years you spent at Monsanto, a lot has changed ever since you started until now in terms of technology and the way farming is done. Isn't that correct? Absolutely. In fact, I was very fortunate to join Monsanto when the first GMO cotton was introduced into the country, and I was quite involved with that.
Hey, we're going to get into that one later, this GMO. We're going to get later into it. So, I mean, for those of us who don't know, let's talk a little bit about seed technology before we do. I mean, we've done a lot of development within seed technology. Just give us briefly how far we are right now.
Yeah, that's a difficult one to sort of say how far we are, because we keep learning and doing things better and better. But I always like to sort of say seed technology or the seed is kind of like a bucky on the farm. So you have certain sort of standard features on the bucky, the engine, whatever. But as the technology improves, you can tweak the engine so you get a little bit more power out of it. The seed produces a little bit more yield. So that's one part of seed technology, is the breeding and how you develop varieties and hybrids that have higher yields, or they might have some resistance to some diseases, or they germinate better. So that's almost like the engine and the bucky. But then there's another aspect to seed technology that we talk about. You mentioned it just now, the GMO side. So that's like a specific trait that you add. So that could be something like a better audio sound system in your bucky. It's just one specific thing that you add. And on the GMO side, that has largely been insect resistance to particular pests, or the ability to spray a herbicide on the crop plant and not kill it, herbicide tolerant. Beyond that, the seed technology goes even further. So if you think of your bucky, all the things you can load into the back of the bucky. So you could, and that side of the seed technology is like all the seed dressings. So you can add pesticides onto the seed so that when you plant it, that seed is protected. You can add various fertilizer types so that the seed germinates better. So all of those things give the bucky a little bit more go than it would have had otherwise. And I think just like in the automotive industry, the technology is advancing, the same in the seed industry. There are better and better processes. At the end of the day, that little seed that you plant is actually like a miracle. It's got so much technology packed into it to really, how can I say, make your chances of producing a good crop so much better than the 30 years ago that you were speaking about. Yeah.
I mean, speaking of the 30 years ago that I started off with, the world population is growing at a rapid pace. I mean, there's like 8 billion of us now. Yeah. So how important is it to keep on developing seeds in order to feed all these people?
It's amazing, actually, because that story about the overpopulation of the world and there's not enough food, it never really seems to come true. We make those advances and we keep producing more and more on less and less area. And I think that's the trick. That's what we need to keep focusing on. So yeah, there are still a lot of people that live below the poverty line, etc. But actually, even though the number of people, the global population is going up, less and less people are living under the poverty line as time goes on. And a lot of that is a testament to all the technology that we have in agriculture. Maybe one of the examples is, I don't know, around the early 1990s, late 1980s, South Africa was producing about 10 million tons of maize on about 4.5 million hectares. Today we produce about 16 million tons of maize on about 2.5 million hectares. So you can just see how we have globally been able to up the production, so we get more per hectare. That makes sense, yeah.
No, it does, absolutely. I mean, at the end of the day, you need to be innovative, right? And use whatever you have more effectively.
Yeah, and also with less impact on the environment as well, because in the past, again, they were very necessary at the time, but we had some pretty harsh insecticides and pesticides. Today, they're much softer than they used to be. They have less of an impact, and they allow us to produce more of the crop than we used to be able to. Yeah.
So, now that you mentioned pesticides and insecticides and whatnot, let's get into what people call GMOs. Let's just start from the basics. From the basics, what is GMOs?
Abbreviation GMO stands for genetically modified organism. So again, I don't know at what level we want to go in, but as you know, every living organism has DNA in it, and it's the DNA which is the it's the material that the next generation inherits with the characteristics of the previous generation. So this applies to animals, plants, everything. So DNA is made up of 4 different building blocks, adenine, thymine, cytosine, and guanine, ADTC. And depending on the order of those building blocks, that produces the product, a protein or a structural part of that organism. So depending on what you inherit and the order of those building blocks, you have the offspring that comes, whether that's a plant or an animal or whatever. That's the basics. It's almost like Lego. You can buy a bag of Lego, and depending on how you put those blocks together, you can build a motor car or a house or a sailing boat or whatever. It's kind of the same with DNA. So across all living organisms, DNA is the same. It's made up of these 4 building blocks. And so it's interchangeable. And that's actually what's happened with the GMO. They've been able to find a particular grouping of these building blocks, which we call a gene, that produces a particular protein. And in the case of insect resistance in crop plants, that gene came from a bacterium. This bacterium is called Bacillus thuringiensis, BT, and this bacterium has been used for many years, way before GMO time, to spray onto crop plants because it produces a protein that is toxic to the worms that eat the plants, particularly in vegetables. So what the scientists were able to do was to isolate that gene, that grouping of the Lego blocks, and insert it into a maize plant or a cotton plant They can do that because it's the same stuff. It's the same adenine, cytosine, thymine, and guanine. So once that gene is now in our crop plant, it starts producing that same protein that it always did in the bacterium, and that protein is toxic to the caterpillar. So our maize plant or our cotton plant is now producing that protein. So when the worm comes along and eats it, it obviously has the same effect on it, and it dies. What's really cool about these proteins, though, they're not effective in mammals or warm-blooded animals.
Mammals meaning us.
Humans, cows, pigs, whatever, it has no effect. If we do get some of that protein in, it's exactly the same as eating a steak. We digest it up and get energy from it, and off we go. It's non-toxic to mammals and humans. And that's a big step forward from the previous kind of pesticides that we used to have. Much safer, much more effective, because that plant is being protected, it's producing the protein 24/7, whereas in the old days when you had to go out and spray, that spray was probably only good for 3 or 4 days. That's one of the GMOs. There are lots of different traits, lots of different arrangements of these building blocks, genes that have been identified and placed across. Yeah. The process of getting that gene into the crop plant is very complicated. And I don't know if you want to go down that road or not, but there's 2 pathways to do that.
So speaking of the process, you don't have to go in depth of it. Reason why I'm asking this question, what is GMOs, is that there's a lot of misunderstanding. Absolutely. Is actually the correct word to use about GMOs. That's why I'm happy you clarified that it does not harm mammals.
No.
And another thing is that people say, yeah, but this is all chemicals. Is there any chemical involvement in this?
Yeah. So everything is a chemical, essentially, at the end of the day. If you think about the periodic table with hydrogen, helium, whatever, and then you take substances like water, which is a mixture of hydrogen and oxygen, everything is a chemical. Everything around us is made up of those chemicals that we find on the periodic table. But it's the combinations of those, like the building blocks, the combinations of those chemicals that give us our different substances. So DNA is definitely a chemical. The protein that GMO produces is a chemical. But so are some of the insecticides that we used in the past. They're also chemicals.
Yeah, absolutely.
Yeah, I think maybe what we really need to understand is that before a GMO gets approved for sale, there's a whole long regulatory process. The scientists that develop the GMO, as well as experts in government, regulatory bodies in government, they're the ones that have to approve it. So the scientists gather a whole lot of information that the regulators want to know about, and they submit that, and it goes through an independent panel. In South Africa, there's an advisory committee. Nobody really knows who's on that advisory committee, so there's no pressure on them. They're mostly independent academics, and they look at all the evidence to see whether this GMO, this arrangement of building blocks, could be harmful. And if there's a slightest possibility that it could be harmful, could be maybe a protein that develops an allergic reaction, they won't approve it. They have to be 100% certain that it's not going to be harmful. And at that point, when they approve it, only at that point can the company that developed it commercialize it and take it to market. We need to trust our scientists. We need to trust our regulators. They do a good job. There are several applications that they've refused and others that they approved. They're very objective. And so I just feel that the public, that's the purpose of a regulatory system. The public can be confident when a product comes to market that it is safe.
Ladies and gents, do you see how important that science class is in high school? Don't fail science, because you are the future who's going to determine what I eat as an old man. Anyway, Andrew, now this development obviously costs money. Yeah. Now let's talk about what you guys do at Sacta, and particularly the Sacta Levy. Let's start there. What is the Sacta Levy and what is it for?
So Sacta stands for the South African Cultivar and Technology Agency. So cultivar is a word that encompasses both varieties and hybrids. It's what comes out of breeding programs from seed companies. If we look at a hybrid, like maize or sunflower, that seed that a farmer plants is made up by crossing a male line and a female line to produce a seed. When that seed is planted, it produces a crop with a much higher yield, so-called hybrid vigor effect. But if you take the grain that hybrid produced and plant it back again, it would segregate back to the 2 parents. And they are normally low yielding. So in the cases of hybrids, farmers buy new seed every year because they want to get that hybrid vigor. But you get other types of plants that we call open-pollinated plants. And in those plants, the grain that you harvest is exactly the same as the seed. It comes from a pure breeding line, and it doesn't segregate back to its parents. So essentially what you can do, a farmer can keep that grain and use it as seed. Now, seed companies cost them a lot of money to develop a new hybrid, and if the farmer is going to keep the grain back and plant it as seed, they don't get a return on that. So over time, that breeding effort on open-pollinated crops has actually sort of tailed off. When I say time, I'm talking 2-3 decades. And our yields of these kind of crops has stagnated. It's pretty level. You can add all the other technology you want to it, but if the engine of the bakkie is not more souped up or whatever, you're not going to get more out of it. Yeah. So the industry came together. They realized that the yields were stagnating, and they came together with this idea of let's have a statutory levy, so that every ton of this grain of open-pollinated crops that gets delivered, we take a portion of that money, and it's a very small portion. It's like 1% of the commodity price. And we'll channel that back to the seed companies as an incentive to develop their breeding programs and develop new varieties that have higher yields. And that's what Sacta does. They administer the collection of that levy and the dividing up of it back to the beneficiaries.
What is the difference between a hybrid and an open-pollinated crop?
So as I was saying earlier, the hybrid is a seed that comes from 2 parent lines. These parent lines are pure breeding, generally speaking, and when you cross it, you get a seed that has both the characteristics of both of the parents, but somehow it's like synergy. It's 1 + 1 = 3, and you get a higher yield. But if you plant that seed or the grain that's produced, it goes back to the parent lines, and so you get lower yields again. You don't get that extra boost. An open-pollinated crop, on the other hand, is where it's basically the pure breeding line. It's like one of the parents. So this has been bred up over years to produce a higher yield or to resist a disease. And the grain let's take soybeans, for example. You plant the soybean, it produces a crop. The grain that you take is exactly the same as the seed that you planted. So that's why the farmers, instead of going to buy new seed, which is expensive, they keep planting that, and they don't suffer any yield loss as you would with a hybrid if you'd done that. But on the other hand, it's no incentive to seed companies to develop better yielding hybrids. So it's very important. So at Sacta, we collect a levy. The levy has to be applied for and approved by government. And once that levy has been approved, then for every ton of that grain that gets delivered, we get a portion, and that gets divided up and sent back to the seed companies. Crops on which a levy has been approved that Sacta is mandated to collect are soybeans, wheat, barley, oats, and lupins. And for all of those 5 crops, if you take the grain and plant the seed, you get another crop that looks exactly the same.
A hybrid? Maize, ne? Yeah. Maize is a hybrid.
Maize is a hybrid. Most maize is a hybrid, yes.
And soybean is more open-pollinated?
Absolutely.
What else is open-pollinated?
Things like cotton, and basically, you even get some maize varieties that are not hybrids, that are self-pollinating. Some of the older varieties, and I'm talking sort of 1940s, 1950s, in those days, maize was all non-hybrid. It was varietal. Then the scientists, all part of the seed technology we're talking about, learned that if you cross 2 pure breeding lines, you get this offspring that produces a better yield. A lot of the vegetables are open-pollinated, but there are also a lot of vegetables that are hybrid as well. So sometimes, in a household, you might save some seed back and plant it, and then you wonder why this doesn't look like the same thing that I grew last time. Yeah.
So, what else do you guys at Sacta use the levy for?
20% of the levy must go to transformation. And I think you're going to go into that a bit later, but the deployment of that 20% is set out in guidelines that are issued by the National Agricultural Marketing Council And so Sacta follows those guidelines very closely. But essentially, most of that money is used for input production costs for farmers. Some of it's used for bursaries. Some of it's used for sort of socio-economic upliftment programs. But the main focus is developing farmers, yeah.
I mean, later on, you guys at Sacta have, like, can I call it an event?
We need to report back to the public and to stakeholders what we've been doing the previous year and so on. So every year we have an event anybody can register for and log into and watch the proceedings virtually. Obviously, some people will be invited to the event physically as well. But in that event, we will report back on our finances. We'll report back on what we were doing with that 20% money. And then we also try and get a few guest speakers to come and make the day a bit more interesting and so on. So, yeah. I'm
interested about this event. So let's say now I'm a member of the public.
Yeah.
And can I just go into your website and log on, or how does it work?
So you can go to our website. We've sent out a lot of invitations. You need to register for the event. I'm sure on the website you'll find that ability to register. And then you log on, and then on the day, which is the 20th of August this year, you can log in and follow what's going on. I think we even have the opportunity for you to submit a question online, and that will come into the various panels and so on at the event, yeah.
I mean, Andrew, I can sit here and talk with you the whole day. I mean, there's this thing called genome editing, which is a whole other ball game right there. Yeah. So, looking at the future of seed technology, I mean, there's a lot. What do you know which you are excited about, which is coming up?
Genome editing?
Well, okay, genome editing. Let's go into it.
From a seed side of things, I think that's the next sort of big thing, like GMOs were 20 or 30 years ago. And it's interesting that GMOs still elicit a lot of negative reaction, but actually it's really good technology, and it's allowed, well, certainly it's South Africa and other countries that employ that technology to really boost their production. The next sort of new technology is so-called genome editing. It's abbreviated GED, genome editing. It's also a little bit controversial, but it shouldn't be. I'm probably sticking my neck out a little bit. So if we think about the old GMOs, we were actually taking some DNA from a different species and putting it into our crop plant. With genome editing, there's none of that going on. What actually is happening, the technology allows one to switch a gene off. So that, for example, a gene, a set of building blocks that produces a protein, you can switch that gene off so that that protein is not produced. And in many cases, when you're breeding a crop plant, you get a whole lot of stuff that you don't really want in that crop plant that drops the yield. So if you can identify those genes that are causing that and you can switch them off, the yield goes up.
Just like that?
Just like that. So what's nice about some of these genome editing products is that there's no foreign DNA coming into it. It's what has been developed, let's say, naturally, but you're just switching a gene off, or you're taking another gene and telling it to make more of that protein. It's incredible technology. The real benefit around this is that it probably doesn't need as much regulatory oversight, because you're actually dealing with something that exists naturally. You're not adding anything to it or shuffling things up at all. And so I think that's the next big one. I'm not sure, there are a lot of genome edited science going on and products. It seems to me, and I'm not expert on this at all, that the real application for these kind of products is going to be in disease resistance. So with the GMOs, we had insect resistance, and you kind of needed a whole gene or two genes to produce new proteins to kill the insect. Because an insect's a complicated animal, it's quite advanced. Whereas a disease is like a bacteria or a fungus. It's not quite as complex as an insect. So I think by these smaller tweakings that genome editing delivers, you're probably going to get products that can control diseases, but you wouldn't be able to get a product that controls an insect or something that's more complicated.
Listening to all this right now, I'm thinking, there is so much that goes into the food I eat on a daily basis. So what is your What is, should I say, your dream for the agricultural sector in SA?
It's a tough question, that, because I think if you're involved in agriculture, you kind of get locked into the process, and there are new developments that come. And actually, it all comes together on the farm level, all these technologies. So we talk about seed technologies and some of the GMOs and stuff. But outside of that, there's guys working on new types of fertilizer that deliver more of the nitrogen, whatever, better, more efficiently. One of the other really new technologies that's interesting is this sort of geospatial mapping, where you can set up your field and your tractor and your planter to plant a particular density of seeds. And it's so precise now that if you know that this area of the field has got better soil or whatever, you can actually tell the planter to push up the plant population there. But when it gets to the bad part in the field, it can drop the plant population. So those kind of technologies are also very exciting, and I think they really promote efficiency. And then when you pull all of these technologies together and you make it all comes together in the field ultimately. How do we go forward in South Africa? I think it's just a continual sort of improvement process. There are all these different folk working on these different aspects, but the magic happens on the farmer's field when all these things come together. And our farmers are actually particularly talented, I think, because they seem to be really innovative in learning very quickly how to pull all these technologies together and make it work for them. Yeah. And I think we can be very thankful for the farmers in this country, because they are producing food at a fairly low, relatively low cost globally, and the quality of the food is very good. We have the regulators in the department making sure that what we get is good. I don't think we need to worry about the food that we eat. If it gets onto a shelf, it's fine. There have been so many eyes looking at it to make sure that it's safe for us. Yeah.
Andrew, thank you for popping by.
Thank you for the opportunity. It's always great to talk with you. And as I say, if I can end with one thing, is we need to trust our scientists. Scientists are the future.
Well, you heard it for yourself. We need to trust our scientists. But also we need to trust and appreciate our farmers. There is so much that goes into that loaf of bread that you buy, or that pap that you buy, or even that steak that you eat. Please, guys, appreciate the agricultural sector. And for those of you who want to go in the agri-space, go, Buffett. You just heard for yourself, there's vast amounts of careers that you can go into. Thank you so much for popping by at AmaFama, and see you on the next one.